let's talk about one of the most interesting and honestly weirdest challenges in tech right now. How do we make AI more accurate? Because as you're about to see, when an AI gets something wrong, it doesn't just make a little oopsie. No, it can be confidently, fantastically, and sometimes just hilariously wrong. Okay, let's get into it.
So, first things first. We all make mistakes, right? But AI makes mistakes that are just on another level. They're not like human errors. An AI can literally invent facts out of thin air, cook up solutions that make zero sense, and then present them to you like they're the absolute truth. People call this hallucinating, and it's the #1 problem we have to fix if we're ever going to truly rely on these things.
And this is a perfect example. Imagine you ask an AI for help because the cheese and pepperoni keeps sliding off your pizza slices, and it tells you, with a straight face, to use industrial-strength glue. Now, you and I know that's insane, right? But a chatbot might genuinely suggest it. This is exactly what we're talking about. AI's totally flawed, non-human logic in action.
So this gets us to the big question, doesn't it? Why does this even happen? How can a system that is so mind-bogglingly powerful also be so incredibly, confidently wrong about things? You can even tell it, try again, and it'll apologize and then spit out something equally bizarre. It really makes you wonder, what parts can you even trust? And more importantly, what can we do about it?
Okay, so the first and maybe the most important solution starts with what we feed the AI in the first place. See, an AI model's knowledge is basically frozen in time. It only knows what was in its training data. So if you ask about something brand new or super specific, it has no choice but to guess. So rule #1 is to give it a way to access fresh, reliable info. And the best way to do that is with a really powerful technique called retrieval augmented generation, or RAG for short. The idea behind it is actually pretty simple, but it's a game changer. Instead of just relying on the AI's static old memory, we basically give it a cheat sheet. We connect it to a trusted, up-to-date knowledge base that it can check before it even tries to answer you. So how does RAG actually work? Well, it goes like this. First, you ask your question. The system is smart enough to see that it needs some outside info, so it sends out a little retriever. Think of it like a super-fast research assistant to scan a trusted database for anything relevant. Then, it takes that info it found and literally staples it onto your original question. That's the augmented part. Finally, this new and improved prompt gets sent to the AI, which now has all the context it needs to give you a way more accurate answer.
But look, just throwing better data at an AI isn't the whole story. You also have to pick the right AI for the right job. You know, not all models are created equal, and choosing the correct one is absolutely critical. It's just like anything else in life. You wouldn't use a hammer to saw a piece of wood, right? You need the right tool.
So on one side, you've got these huge, general models. They're like the jack of all trades. They know a little bit about everything, from ancient history to modern art. But on the other side, you have these smaller, specialized models that are deep experts in just one thing, like, say, cybersecurity. You wouldn't ask your family doctor to fix a computer virus, and it's the same idea here. For those expert questions, a specialized model is always going to give you a better answer.
There's another setting you can tweak called temperature. Think of it like a creativity dial. If you turn the temperature down low, the AI becomes really deterministic and predictable. It sticks to the facts. Perfect for science questions or anything where there's one right answer. But if you want it to, say, write a poem or brainstorm some crazy ideas, you crank that temperature up high, and you'll get much more varied, creative, and sometimes surprising results. The key is matching the temperature to the task. Okay, next up is a technique you probably remember from math class, showing your work. It's a method called chain of thought prompting, and it's all about forcing the AI to lay out its reasoning, step by step, instead of just blurting out an answer. And believe me, this makes a huge difference in cutting down on errors, especially for problems that need logical thinking.
So check out this classic problem that trips up AIs all the time. A factory makes 3 times as many red widgets as blue ones. In total, they make 240 widgets. The question is, how many of those are blue? Now, there's an answer that kind of feels right, but it's totally wrong.
And there it is, 80. That's the quick, gut reaction answer you get if you just divide 240 by 3. And it's exactly the kind of intuitive leap an AI might make if it doesn't actually think through the steps. But nope, that's not it.
But see, when we force the AI to use a chain of thought, it has to lay out its logic. It has to define its variables, set up the correct equation, which is red plus blue equals 240, and then substitute to figure out that 4 times the number of blue widgets is 240.
And that logical process leads it step by step to the right answer, 60. It completely avoids that gut feeling mistake.
So far, we've focused on how to make a single AI smarter. But what if we used more than one AI brain to solve a problem? This next batch of techniques is all about using the wisdom of the crowd, so to speak, to get a much better, much more reliable answer.
The first approach is called LLM chaining, and the idea is pretty straightforward. Instead of just asking one model, you pass your question through a whole series of different models. It's kind of like getting a second, third, or even fourth opinion from a panel of experts before you make a big decision. So here's how that flow usually works. The first AI takes a crack at it and creates an initial draft. Then, that draft gets passed to a second AI, whose entire job is to critique it and make it better. Then it might go to a third and a fourth. Each AI in the chain builds on and improves the work of the one before it, which leads to a final answer that's way more polished and reliable.
Now, a similar idea, but with a twist, is called mixture of experts, or MOE. This is a bit like LLM chaining, except it all happens inside one single massive AI model. This one big model is actually made up of lots of smaller expert submodels, and each one is a specialist in a different area. The best way to think about an MOE model is like a single human brain. When you ask it something, there's an internal router that figures out which parts of the brain are best for the job. A math problem? That gets sent to the math lobe. A question about poetry? That goes to the language lobe. Then their outputs are all combined into one final answer. It's a really smart way to get expert-level results from just one model. So, as you've probably figured out by now, there's no single magic wand we can wave to fix AI accuracy. The reality is, getting to a reliable, trustworthy AI isn't about finding that one perfect trick. It's about combining all of these different strategies into a complete toolkit. So, let's quickly recap the main tools we've talked about. We started by grounding our AI in reality with retrieval-augmented generation. Then we learned to pick the right model and set the right temperature for the task. We forced the AI to think logically using chain of thought prompting. And finally, we used the wisdom of the crowd with both LLM chaining and mixture of experts. Each one of these is a really powerful tool for making AI better.
All these techniques are making AI more and more accurate every single day. And that brings us to one final, much bigger question. It's not really a matter of if AI will become incredibly accurate. It's a matter of when. And as we get closer and closer to that point, how do we, as people, as a society, decide when it's accurate enough to really trust with the important stuff? It's definitely something to think about. Thanks for tuning in.